The interesting thing about the I Ching, even its skeptics agree, is that it seems to work. Very puzzling. Other forms of sortilege seem much less certain. Here's what I think is happening. First of all, let's look at the Western notion of time as we derive it from Newton. The Western notion of time is that time is what is called pure duration. All time is, in Western physics, is the place where you put process so that it doesn't all happen at once. Time has no quality. It's pure duration. Think of it as a perfectly smooth surface. The only modification to this doctrine in the past 500 years is Einstein came along 100 years ago and said, in the presence of massive gravitational fields, this perfect smoothness is slightly distorted over very large scales. So we go from perfectly smooth, pure duration to very slightly curved space-time. But the main idea, which is contiguous through all of these intellectual evolutions, is the idea that the local fine structure of time can be portrayed as a zero-dimensional space. If that's too technical for you, it means that locally it is okay to think of time as perfectly smooth. I say it isn't. Why should it be? This has to do with a form, remember we talked about sentimentality and how it can distort thinking. This adherence to the idea that time is perfectly smooth is a sentimental notion left over from our infatuation with perfect geometrical shapes when Greek science kicked off about 2,500 years ago. It took Kepler and Copernicus to demonstrate that the orbits of the planets were not perfect spheres because God loves, or perfect circles, because God loves perfect circles. And one by one, the perfect objects of Greek mathematical and geometric theorizing have been laid aside. The planets do not move in perfect circles. Nothing else has been found to have mathematical perfection, except that this idea of pure duration has been hung on to. And there's a reason for this, and I apologize for the digression, but it's very hard to snip the loose ends on a thing like this. The reason this idea of pure duration has been hung on to is because science, modern science, does its business through a series of hat tricks called probability theory. And probability theory is the idea that you can learn something useful about a phenomenon. Let's say, for instance, you want to know how much voltage is running through a wire. Strange thing about this value that you come up with is this. It is not necessary that it correspond to any one of the 1,000 measurements that you took. It's entirely possible you will get a value that is not congruent with any one of your measurements. But we say with confidence, well, it's the average. It's the average. Lurking behind this notion, average, is the unexamined assumption that time is completely uniform, that it does not matter when the measurement is made. And now, why do we assume that? Is there any reason to assume that? Well, not looking at nature, no, there is no reason to assume that. Looking at science, hell yes, there's a reason to assume that. You can't do science unless you assume that. Because science depends on what is called the experimental method. An experiment is you arrange a funny little unusual situation which is designed to cause some phenomenon normally lost in the noise of being to be thrown into high relief. And basic to the idea of experiment is what is called the restoration of initial conditions. In other words, we're going to roll a ball bearing down a ruler and measure its velocity. And we do this. And then we say, restore initial conditions. That means pick up the ball bearing and move it back to the top of the ramp. But now notice that time has passed since the first time the ball bearing rolled down the ramp. If time is not uniform, then you cannot restore initial conditions. If you cannot restore initial conditions, you cannot make sense of probabilistic data. So we have assumed and preserved this sentimental notion of Greek science because it makes it possible to do modern science. If we were intellectually honest about what's going on, then what we really should say is that probability theory and modern science is the study of those natural phenomena so coarse-grained that an assumption of a restoration of initial conditions does not destroy the integrity of the phenomenon. In other words, it's a lens that can be focused only to a certain depth. And beyond that, it begins to give false data. Of course, ball bearings always roll down ramps the same way. Of course, two liquids always mix together in the same way. But who cares about these things? What we're interested in are love affairs, dynastic transitions, corporate takeovers, political revolutions, family feuds. And the interesting thing about these things is they never happen the same way twice. Have there ever been two identical births, divorces, love affairs, corporate takeovers? Of course not. We would not even expect such a thing. We understand that the complexity of those phenomena ensures their uniqueness.